Welcome, students. We recently looked at how to add and subtract polynomials, and today we're going to look at how we multiply polynomials. There are several different methods for multiplying polynomials, and which method we use depends on how many terms there are in the polynomials. And even then, there are sometimes different methods that you might see in a textbook. There's vertical methods, there's horizontal methods, there's table methods, there's all sorts of methods. I'm not going to cover all of them. I'm going to cover, in my mind, the simplest method for each type of multiplication. So we're going to learn three methods, and we're going to start with method number 1. This is just my numbering system. This isn't known across the world as method number 1. And we use this when we have a monomial times a polynomial. And the example we'll look at is 3x squared times 5x cubed plus 2x minus 1. Now, the requirement for using this method is that one of them has to be a monomial. And in this case, the monomial is 3x squared. Do you have any thoughts about how we can multiply 3x squared times 5x cubed plus 2x minus 1? Usually, a lot of my students have some intuition that tells them we want to try and use the distributive property. And if you had come up with that as a thought, you would be absolutely correct. This method, method 1, is the distributive property. All right. So let's distribute 3x squared into the trinomial over there. Now first we have to take 3x squared times 5x cubed. 3 times 5 gives us a coefficient of 15. And then x squared times x cubed gives us x to the 5th. Remember, when we multiply two different exponents with the same base, we need to add those exponents. So this becomes 15x to the 5th. This is why we looked at the rules of exponents before multiplying polynomials. Now, for the next distribution, we take 3x squared times 2x. 3 times 2 is going to give us 6. And x squared times x gives us x cubed. So that term is 6x cubed. And then we have 3x squared times negative 1. That's going to be negative 3x squared or minus 3x squared. And this is our answer. We have multiplied two polynomials together, and our result is one polynomial that represents the product. Now you can do this whether the monomial is on the left or if it's on the right. If it's on the right, you're distributing from the right. And this is the only example problem I'm going to do here. So if you want to see more of them worked out, definitely click on the link below and watch some of those example problems. What we're going to do now is we're going to jump to method 2. And this method is used when we have a binomial times a binomial. For example, we might have 3x minus 2 times 5x plus 7. Now here we could try and use the distributive property. You can consider 5x plus 7 to just be one thing, and you could distribute it to the 3x and to the negative 2, and then you'd have more distributing to do. That will work out, but there is a shortcut that we use when we're multiplying a binomial times a binomial, and that shortcut is called FOIL. You may have seen it before. FOIL stands for first, outer or outside, inner or inside, and last. And this tells us which of the terms in the binomials we need to multiply together. So here's what I'm going to do. I'm going to write out FOIL below this polynomial, and I'm going to show you how foiling works. So we start with F for first. What that means is that we have to multiply the first terms in each polynomial. So in this first one, the first term is 3x. In the second one, the first term is 5x. So when we multiply 3x times 5x, we get 15x squared. Those are the first terms. Then we move to O, which stands for outer. So we look at the terms on the outside, 3x and 7. Those are the ones that are touching the outer parentheses. Now when we multiply those, 3x times 7 is 21x. So that outer product is going to be 21x. Next, we move to the inner terms. Those are going to be negative 2 and 5x. Those are the ones that are touching the inner parentheses. Now, negative 2 times 5x is negative 10x. So that's that product. And then finally, we have our last terms. Those are going to be negative 2 and 7. Those are the last terms in each of those binomials. Negative 2 times 7 is negative 14. And this is what we get after we have done FOIL. 15x squared plus 21x minus 10x minus 14. There's one more step to being finished here. We can combine like terms. When we do that, this gives us 15x squared plus 11x and then minus 14. This FOIL method works whenever we have a binomial times a binomial. It doesn't matter what the terms are, we can always multiply the first terms, the outer terms, the inner terms, and the last terms, and that ends up giving us all of the terms that we need. We can combine like terms if they exist, and then we have our final answer. All right, that is the second method. Again, I'm not going to go through any more examples in this video. You're going to have to click on the link below and look at some of those examples there to get practice. The reason is I don't want these videos to be an hour long. I want to give you these pieces of information in small chunks and then allow you to look at the other videos at your own pace, to decide which of them you need to look at, how many of them you need to look at, and then you can move on to the next one. So we have one more method that we're going to look at. This is method 3. And this is the one that doesn't have any restrictions. We can use this with any polynomial times any other polynomial. And there are actually multiple ways of doing this. There's a vertical method, there's a horizontal method. Some books cover both of those. But I have found that students always find the table method to be the cleanest. Let me show you one example of how we can use the table method to multiply two polynomials, and then you can look at some more examples on your own time. So let's take a look at 3x squared plus x plus 5 times 2x minus 1. Now we can't use foiling here because this is a trinomial. Foiling only works when it's a binomial times a binomial. The distributive property would be a little bit complicated because none of them are monomials. We could distribute this 2x minus 1 to each of the terms in the other, but that would end up with a lot of work. We'd have to use the distributive property 3 more times, and it just ends up being cluttered. What we're going to do is we're going to organize all of our steps here with a nice table. Now, because our polynomials have 3 terms and 2 terms, we're going to make a table that has 3 columns and 2 rows. We're going to make a 3 by 2 table. You could also make a 2 by 3 table. Doesn't matter what order we're dealing with. And here's what we're going to do. We're going to take all of the terms and we're going to put them on the tops of the columns and on the left sides of the rows. The first one's a trinomial, so we put those 3 terms on top of the 3 columns. The second one's a binomial. We put those 2 terms to the left of the 2 rows. And then to fill in all the blanks, we multiply whatever row and columns we have. So for this first one, it's in the 2x row and the 3x squared column. 2x times 3x squared is 6x cubed. For the next cell, we multiply 2x times x. That gives us 2x squared. And for the last one in that row, we multiply 2x by 5, giving us 10x. Then we move to the next row, and we multiply all of those by -1. -1 times 3x squared is -3x squared. -1 times x is -x. And -1 times 5 is -5. Now that we've filled in all of the cells in that table, we need to combine like terms to get our final answer. And most of the time when you do a problem like this, the like terms are going to end up being diagonally adjacent to each other. That happens whenever we end up having the polynomials in standard form. It's really nice. So if we look at the x cubed terms, we just have 6x cubed. If we look at the x squared terms, -3x squared plus 2x squared gives us a -x squared. If we look at the x terms, 10x minus x is 9x. And then we just have that one constant term that we bring down, and we end up with 6x cubed minus x squared plus 9x minus 5, which is our final answer. If we had a problem that was a trinomial times a trinomial, we would have to make a table that was 3 by 3 so that it's big enough to deal with all 3 terms of each of them. If we had a polynomial that had 4 terms being multiplied by a polynomial that had 5 terms, we would have to make an even larger table. The size of the table corresponds to the number of the terms in each of the polynomials. All right. For more examples, including some 3 by 3s, take a look at the linked videos below.